It gives me enormous pleasure to talk to you today about the periodic table of the elements as part of the Royal Society of New South Wales contribution to Science Week 2020. As a chemist, it underpins everything I do. And in recent years, I've also had a very, very small hand in naming elements, as we shall see. So with these rather shaky credentials, let me take you in a ramble through the strange medley of haphazard facts falling into line and order, as C.P. Snow says. So, the meme of the periodic table is so pervasive in modern culture that the 150th anniversary of an early go at the modern form, Mendeleev's 1869 table, has become the subject of worldwide interest. There are ties, mugs, tea towels, and fridge magnets. Indeed, the idea of the table of elements is so cool that its form has been borrowed by all kinds of enterprises. But perhaps the strangest to me, anyway, being a layout of the books of the Bible. So, the periodic table is there for chemistry as Darwin's Origin of Species is for biology, or perhaps Newton's Principia for physics. But it's unique because the thing itself can be written on a single sheet of paper. All the information resides on that one page. So I shall now take 40 minutes to introduce it to you. We'll look at the concept of an element and how that's matured to our present view. A few stories of element discoveries and the first attempts to draw together the similarities and differences among elements, early attempts at the periodic table. Mendeleev takes center stage as it's the 150th anniversary of this periodic law. But to finish, I'll explain how we decide on new elements these days and how they're named, because that's what I do. And perhaps how to get an element named after you. I thought I'd start, though, with some trivia questions. Have a think about them while we're talking. I'll give you some of the answers, but I'll give you all of the answers at the end. So, who was the only female to have an element solely named after her? Who was the first living person to have an element named after him? And what's the first element discovered in Asia? Who discovered oxygen? Who invented the 1 or 2 letter descriptions that we use for elements today? What's the heaviest element with at least one stable isotope? And indeed, what are the 2 elements, themselves unstable, but sitting among a whole bunch of very, very stable elements? We shall see. Clearly, the whole periodic table thing starts with the concept of an element. Now, you don't have to be a philosopher to ponder on the richness of things in the world. Solids, liquids, gases, all gazillions of stuff. And you might want to offer a solution by positing a subset of elements that perhaps when mixed and matched gives rise to all the different matter in the world. So I've circled here on this periodic table the elements that were known in antiquity. So there's not too many of them. And of course, they weren't known as elements in those days. In fact, if we go to dear old Empedocles of Akragas in Sicily, he writes of the 4 roots by which all things are made. These are identified now as the elements earth, air, fire, and water. And that held sway for an awful long time. Empedocles actually comes up with a really rather far-sighted concept as well. And he said that in order to make everything in the world out of these 4 elements, you needed forces. You needed a force to bring them together, and you needed a force to split them up again and remake them. And he called these two forces love and strife, which is rather splendid, I think. Anyway, after all of that, everybody and his mother wanted a go at the idea. But in fact, we'll jump to Lavoisier, who went to the guillotine in 1794 and was really one of the absolute greats of science, but certainly chemistry. Here he is in a painting by Davy with his wife. Lagrange, the French mathematician, says, "It took them only an instant to cut off his head, and 100 years might not suffice to reproduce its like." Well, of course, they cut off his head because he was a tax collector. Many people get told that story. But in research for this talk, I discovered that, in fact, he wasn't some little government official. He came from a fairly wealthy family, and he decided to invest his, as it were, family fortunes in a tax collecting business. And it wasn't a very nice tax collecting business. And indeed, when the revolution broke out, he really was for the chop. Before that, and in fact, he uses his tax collecting revenue, the profits he made from it, to prosecute his chemistry. He bought a big chemistry set and he did all kinds of experiments. So he comes up with this idea of 33, as he calls them, simple substances. We would call them elements. They included many of the substances we now know as elements, quite a lot of metals and the odd non-metal, but he also did manage 4 kinds of oxygen, air, and 5 kinds of caloric, or feu, fire. In fact, lots of elements were being discovered about then, and bringing them together on one page seemed rather a good idea. As we can see, before 1800, we'd now added to the few from the ancient world, and we were doing pretty well. We'd got 1 or 2, as you can see, of the periods and groups of the periodic table. So the idea of elements was catching on. How do we decide if a particular substance is indeed an element? Well, you do it by reacting with other elements and making compounds, but you never split them up into something simpler. The problem with sorting out chemistry, though, is that when elements combine, they often produce substances that are miles different from themselves. So think metallic sodium and gaseous chlorine giving table salt, or hydrogen and oxygen, 2 gases, giving water, a liquid that doesn't seem to do a lot of reacting. So the early to middle 19th century was the great heyday of the element discoverers. We were getting better at experiments, and the ideas of the scientific method were catching on. Clever people from around the world were discovering that sharing ideas, collaboration, was the way to achieve success. And there isn't a better story than that of the discovery that iodine was indeed an element. In 1813, Sir Humphrey Davy, he's the young gentleman on the left of your screen, the most famous chemist of his age, but of course soon to be eclipsed by Michael Faraday, was awarded a Napoleonic medal for his work in electrochemistry. In fact, he'd used the newfangled electrochemistry to discover quite a few elements. An entirely good choice, you may think. But wait a minute, we're at the height of the Napoleonic Wars. 1813, it's only 2 years to Waterloo. And Sir Humphrey was most certainly, if you're a Frenchman, on the wrong side. But science transcends mere politics. Would that be the case today? And a passport was issued for Sir Humphrey, Lady Davy, his wife, and his young assistant, Michael Faraday, to cross the English Channel and be taken to Paris to collect his medal. However, Sir Humphrey wrote in his diary that they did have some problems at the border when they'd crossed the Channel, saying that they stole all my silk stockings. Dastardly French for you. But safely in Paris, they were asked by the great French scientist Ampère, and asked to have a look, who asked them to have a look at substance X, which is obtained by burning and processing a lot of seaweed, and work out if it was an element or a compound of oxygen. It had been discovered a couple of years earlier by a Monsieur Courtois, and there was a big discussion about whether or not they'd found yet another element. Well, Faraday and Davy had brought their chemistry set with them, and so they set it up, and in a couple of weeks, they had concluded that substance X was indeed an element, and it was related to chlorine. On the way, they'd made nitrogen triiodide, made simply by adding ammonia to iodine. But the thing is that ammonium triiodide, when dried, explodes spontaneously, or at the smallest touch anyway. And as Faraday notes in his diary, we had just time to duck beneath the tabletop before the mixture exploded with great violence. Well, there you go. No doubt windows were blown out and the hotel room trashed. Well, there's science for you. However, Gay-Lussac, in fact, already had claimed the discovery that iodine and the naming of iodine, that was indeed an element. And this caused an enormous fuss for several years afterwards. Davy maintained he'd done it. Gay-Lussac said, well, there was no reason for him to have done it because the French had already worked it all out. And in fact, Ampère was accused of giving the stuff to Davy when really he shouldn't have done. Where was IUPAC when we needed it? Anyway, so who is the discoverer of iodine? Was it Monsieur Courtois, who isolated it for the first time? The person who realized it was an element, Gay-Lussac or Davy, or who named it, or even who was first to publish? Remember the oxygen trivia question? Well, the answers are Shaler, Lavoisier, or Priestley, depending on whether you're Swedish, English, or French. Anyway, where are we with the periodic table? Beginning of the 19th century, it's dawning on us that among the known elements, and 13 are added between 1800 and 1810, there is similarity of properties that appear to repeat themselves. In particular, relationships between atomic weights are being noticed. Now, measuring atomic weights isn't actually so easy, but we can always work out equivalent weights. For example, the weight of a metal that reacts with a certain weight of oxygen, or perhaps a certain weight of an acid. Hydrogen is the lightest element and first in the periodic table. So it's not actually silly to propose that the hypothesis that all the other elements are simply multiples of hydrogen. This is known as Prout's hypothesis and was put forward by William Prout in 1815. And I think it is one of the best wrong theories that I've heard in a long time. It's almost correct, but even with the experiments of the day, it became rapidly evident it really just wasn't right. And of course, it wasn't quite right because of neutrons and isotopes. So perhaps before we continue, let me just remind you what an atom is made of on a scale that a chemist worries about. The nucleus, which gives the atom its mass, has two kinds of particles: the atomic number of positively charged protons and a certain number, often about the same or a little more, of almost the same weight neutrons. Outside the nucleus lives an atomic number of negatively charged electrons, so that gives an overall neutral atom. Unfortunately, neutrons don't do much, and it took us a long time to discover them, till 1932. But the existence of the particle to give extra mass to an atom had been around for quite a long time. Indeed, the word comes from 1899. The isotope of hydrogen, which we call protium, and which makes up about 99.98% of all hydrogen that we find, only has a single proton and a single electron, no neutrons at all. So the reason that poor old Prout got it wrong was that he was really only working with half the particles needed to describe an element. By the way, his famous work is called Chemistry, Meteorology, and the Function of Digestion, considered with reference to natural theology, which shows that they were real natural philosophers in those days. And it's a book, unfortunately, I have never read. He was nearly honored when the proton, eventually when it was discovered, it was suggested that it should be called a Prouton in his honor. Is that right? So we're coming now to the periodic table proper. So by 1869, if you remember when Mendeleev does his first go, as you can see, we've now discovered and isolated an awful lot of elements. And the observed similarity is becoming more and more obvious because we've got more elements to play with. One of the early observations was that in groups of 3 elements, which they called triads, by a man called Brynn from Germany, that they all seem to have similar properties, and the atomic weight of the middle element is the exact average of the elements, of the weights of the elements either side of it. So think chlorine, bromine, and iodine, or lithium, sodium, and potassium. Well, at a conference in the German city of Karlsruhe in 1860, which is considered the first international chemistry conference, and it was organized by Kekulé. If you remember, he's famous for the hexagonal structure of benzene. A revised list of elements with their atomic masses was presented. So now the hunt was really on for the underlying rules of these elements. Well, in 1863, Jean Courtois tried to make sense of triads and the elements that they knew by suggesting a thing he called the telluric screw. I say no more. But then we come to one of the greats. So Julius Meyer, between about 1864 and 69, produced various tables, and he attempted to group elements with similar properties and observed that they were often similar differences between their atomic weights. Not exact, but interesting all the same. He was to have his own stoush with Mendeleev in a few years' time. History has largely forgotten him. I think we now think that while Mendeleev probably deserves the accolades he's got, Meyer really does need an honourable mention on the way. Perhaps so too does a man called John Newlands. We'll see that in this little section, all the great scientists are old men with beards. I say no more. Newland discovered a thing called the law of octaves, which was that there appeared to be about every eighth element, you've got something with very similar properties. And we see his little table. More and more people are putting these ideas down in the form of a table. Although, in fact, it was to be Mendeleev who coined first the word, the periodicity or periodic law. He says, properties of the elements, and thus properties of light and heavy bodies, formed by them are in a periodic dependence on their atomic weight. So that's something he wrote in 1871, published in the Journal of the Russian Physico-Chemistry Society, called The Natural System of Elements and its Application to Indication of Properties of Unknown Elements. Well, here's Mendeleev, complete with beard, looking like Rasputin on a bad day, perhaps, but he has at least an element named after him, and he really is considered the father, if you like, of the periodic table. Although he'd been thinking about elements and atomic weights and classifications really for a long time, he appears to have had his, what you might call, eureka moment, or Eureka Day, on the 17th of February, 1869. He wakes up with this idea of the table of elements. He was so taken by this that he cancelled his trip to visit a cheese factory where he was going as a consultant and decided to work on this thing that was going to become known as the periodic table. And as we've been told, the star quality of Mendeleev's table is that he left gaps for 3 elements and then 4 later on. That elements are yet to be discovered, but he could predict the properties of. And I'm just going to look at the element with atomic weight 72, not element 72, the element with atomic weight 72. And that is, in fact, element 32, now called germanium. He called it Eka-silicon, using the Sanskrit, apparently. And luckily for him, germanium was, in fact, discovered not that many years later, which kind of cemented his reputation. And looking at this table, it is absolutely fantastic. He nails the atomic mass, the specific gravity. The only thing he gets a little bit wrong is the boiling point of the tetrachloride. But hey, who's counting? And this is why he's become, I think, as famous as he has. I think, though, you have to worry a little bit because, in fact, he actually predicted 16 missing elements, of which 8 were only really missing elements. The rest didn't exist. So ether, lots of talk about the ether in those days. What are we all swimming around in? Is there anything? Well, he thought there was an ether, and it had an atomic weight of 0.17 on a scale where hydrogen was 1. He also completely missed the noble gases, because, of course, they don't react with anything, so they're very difficult to spot and say anything sensible about. So, yeah, really, 9 out of 10 for trying, shall we say, to dear old Mendeleev. One of the problems of atomic weights is this of isotopes. Remember, isotopes of an element have the same atomic number of protons in the nucleus, but different numbers of neutrons. And the atomic weight is just simply the average mass of all the isotopes that we find in nature. There are 19 elements with only a single isotope, but the rest have 2 or more. In fact, up to 10 in the case of tin. Now, this causes atomic weights not to be simple whole numbers, and the different numbers of isotopes can cause elements to appear out of order in the periodic table when you only look at the atomic weight. The one that Mendeleev spotted was that tellurium, element 52, and iodine appear to be the wrong way around. Tellurium is heavier than iodine, and yet it comes before it, as we now know, in the periodic table. So there's tellurium, there's iodine. So he decided that they had to reverse their places in his periodic table. And of course, he didn't know why, but of course he was correct. The story of the periodic table cannot be told by an Englishman, as I am, without mentioning the short but very important career of Henry Moseley. He was a young Edwardian scientist, educated at Eton and Oxford, and he discovered a periodicity in the X-ray spectra of elements, which allowed him to prove the concept of atomic number, which of course is so important to the periodic table. This led him to predict more missing elements, this time element 72 with atomic number 72, and correctly order the elements in the periodic table. He was nominated for the 1915 Nobel Prize in Physics, but was killed in Gallipoli during the ill-fated invasion of Turkey by English and colonial troops in early 1915. It's interesting reading about him that coming from Australia, of course, we all know about Gallipoli and the action at Anzac Cove and so on. But in fact, there were heaps more English people there than there were Australians and New Zealanders. And poor old Moseley was a signaller. He was laying telephone lines, and he was shot by a sniper almost as soon as he set foot in the cove. At this point, I'd like to recommend a book edited by Roy MacLeod, Fellow of the Royal Society of New South Wales, which is an analysis of the life and legacy of Henry Moseley, called For Science, King and Country. I would certainly recommend it. Just written a review that will appear in the IUPAC journal Chemistry International. Let's now come to the present day. You may have heard that we have now discovered all the elements up to the end of the 7th period, element 118, Oganesson. So how is modern element hunting done? The last stable element is lead, element 82, trivia question. And after that, it becomes progressively harder to make new elements that don't last very long, despite so-called islands of stability. We'll have a picture of that later. So very briefly, we make new elements by banging other elements together using something called a cold fusion method or a hot fusion method. In cold fusion, we tend to take rather larger elements and put them together, hope we form an even larger element. With hot fusion, we fire with more energy, lighter elements at heavier elements, and away we go. This has to be done in enormous sort of dedicated facilities. And the latter end of the periodic table has tended to be discovered in one of these 4 places. The Joint Institute for Nuclear Research in Dubna in Russia, Lawrence Livermore Laboratory in America, in Darmstadt in Germany, and our one Nihonium, our Asian contribution in Japan, in Riken. So no more Faraday, Davy, silk stockings and the like. I don't think you are going to discover a new element, but you might get one named after you. So who does decide what the new elements are and what they're going to be called? Until 1997, there was a bit of a free-for-all. These activities were going along across the world, as we've seen, and quite often the 2 main players, Dubna and Lawrence Livermore, would, within a space of a few months, discover the same element. And of course, they tend to name it after their own interests and importance. So by the time we get to the 1960s, there are, in fact, more element names than there are elements. And everybody realized it was getting a bit silly. In fact, there was something that has now become known as the Transfermium Wars. Fermium is element 100. So it's all those elements coming after there. Just to give you an idea, here's element 104. The Americans wanted to call it Rutherfordium, so they called it Rutherfordium. The Russians, Kurchatovium. There was, after some long, lengthy discussion, we all agreed on Meitnerium, after Lise Meitner, more of her later. But the American Chemical Society in 1994 decided they'd go back on that, so they reverted to Rutherfordium. In 1995, the International Union of Pure and Applied Chemistry got everybody together, suggested that, in fact, they called it dubnium, after Dubna. Nah, because in 1997, after another big discussion, IUPAC eventually decided to call this element 104, Rutherfordium. Rutherford, of course, is the very famous New Zealand-born British physicist. And this went on. Meitnerium does still exist. It's just a different element, as does dubnium. But clearly this couldn't go on. So IUPAC, since 1997, has been given virtually the sole charge of naming elements and deciding whether we've got new elements. So incidentally, Meitnerium is the only element named solely after a woman. You might think that it would have been Marie Curie, which makes it a good trivia question, but in fact curium was named after both Marie Curie and her husband, Pierre. Einstein called Lise Meitner the German Marie Curie, which I'm not sure is a very good idea. She was an Austrian Jew, fled and started the Second World War, lived most of her life then in Sweden. Turns out she was the second female doctorate in physics that she got from the University of Berlin. In 1917, she discovers protactinium, element 91. And as we can see, element 109 was named for her. Interestingly enough, without too much argument. Just as Henry Moseley had never won a Nobel Prize, although he got shot, she never won a Nobel Prize, who can say? But she was nominated 48 times. But the Nobel Committee in Stockholm never really favoured her. So, who decides if we've got a new element? Well, the answer is a joint committee of the International Union of Pure and Applied Physics and the International Union of Pure and Applied Chemistry. There's something called an expert panel. They throw out up to 10, 5 from each side, worthies. You can see there were 8 in the picture taken here. The lady in the middle with the chart was the president of IUPAC at the time. And they are tasked with looking at the literature, because, of course, all of this has been published, peer-reviewed literature, sometimes 10 years before. So we're looking, has a new element been created? And if so, who created it? So we look at everything that we can and decide who has the priority claim, who first discovered it, not necessarily when it first came out in print, but who submitted the paper that described the new element first. We, the International Union of Pure and Applied Chemistry, then publishes something called an IUPAC technical report. And this is the official declaration of a new element. And as we can see here, this is the one for element 118 in 2016. And of course, when that happens, the presidents of IUPAC and IUPAC get together and issue a joint press release. And that's really splendid because we get into the limelight. Okay, that's the new element, element 118. But what are we going to call it? Well, if you like, you can read these IUPAC recommendations, because these are the official rules for naming an element. It's quite a longish paper, but essentially you can name an element after a mythological concept or character, or astronomical body, plutonium perhaps, a mineral or a similar substance, lithium, lithos, a stone, a place or a geographical region, plenty of those, California, Americium, Berkelium, and so on. Property of an element, like iodine, purple, or a scientist. So, if you're still watching me, the way that you can get an element named after you is to become a scientist. And we've seen quite a few of them. In fact, the answer to the trivia, who was the only living scientist to have an element named after him, the answer is Glenn Seaborg. So the only one at the time. Oganesson, element 118, is named after Oganesson, a Russian scientist who runs the efforts at Dubna and has discovered a large number of elements, as it were. Those are the rules, but how do we actually do it? Okay, the person you need to perhaps novel is the president of IUPAC Division 2, the inorganic division. And the president is tasked with, in conjunction with his or her division committee, to go to the winning, as it were, group, the people who've been identified as producing the new element, and invite them within 6 months to offer a name and a symbol. Now that can go backwards and forwards a bit because sometimes symbols don't quite work. They may have already been taken. We try not to repeat symbols for old elements, even if the symbols themselves aren't used anymore. We don't want to get into any historical confusion. So eventually we come up with a name, Oganesson, for example, and a symbol, OG. That gets published in something called an IUPAC recommendation. Now, this is a paper published in Pure and Applied Chemistry, like a technical report, but it goes through much more reviewing. In fact, it is reviewed by ICTNS, the Interdivisional Committee for Terminology, Nomenclature and Symbols, and at least 15 external referees. Now, I happen to be the secretary of ICTNS, so that's why you see me there. And indeed, since element Copernicium, I've been one of the experts as well. So after some toing and froing, and after 5 months on out for public discussion, the public don't get to say, well, we'd rather have a different name, unfortunately, but they can contribute and comment upon this paper. So eventually, when it's finally accepted, it goes to the IUPAC Council, which is made up of representatives of its national adhering bodies, organizations rather. So that's a representative from every country that's part of IUPAC, over 100. And they then announce publicly through the executive of IUPAC in yet another press release that we do have a named element. And of course, that's when there's a big fuss and we get a lot of very good publicity for our IUPAC. So that's the end of my ramble. Let me perhaps tell you the answers to the trivia questions. Who was the only female to have an element solely named after her? Lise Meitner, as we've heard, not Marie Curie. The first living person, Glenn Seaborg, who was the national advisor on nuclear matters for years and years and years and years. The only element discovered in Asia, nihonium, named after Japan, of course. Who discovered oxygen? The answer being Shaler, Priestley, or Lavoisier. Lavoisier gave it the name oxygen. Shaler probably discovered it, but Priestley actually published first. Who invented the one or two letter descriptions? A man called Berzelius, who's considered the father of analytical chemistry. Swedes get a look in those days. Heaviest element is lead, element 92. We used to think until 2003 it was element 83, bismuth. But in fact, we then discovered that its stable isotope, thought to be stable isotope 209, actually is unstable, except that its half-life is longer than the age of the universe. Sounds stable to me. And our two unstable brethren are technetium, which is right in the middle of the periodic table, but it doesn't exist in a stable form, and promethium, a bit further on. People have produced all kinds of periodic tables in their time. The colourful one is going back to the idea of triads and was suggested only a couple of years ago. And so with that, I'd like to thank you. Just to finally conclude, these are the atoms of elements that we've made most recently. So Oganesson is up there. We're heading into an island of stability. So we are now going to be looking forward to discovering element 119. Work is well underway. We hope to have an answer for you within the next few years, and we can start the 8th row of the periodic table, and I can then give you another little talk. For now, thank you very much for listening to you, and I hope you enjoy Science Week. Thank you.